Hey guys, welcome back to the channel. Today we're going to be solving LeetCode 322 coin change. This is a really famous dynamic programming problem and we'll see why. So feel free to pause the video, read through what the problem is asking for, but I find the examples more descriptive. Okay, so given a set of coins, okay, which is a list, right, of numbers in it, and you safe to assume you have infinite coins, okay, we want to figure out what is the least amount of coins we can pick out to make an amount we were given. So in this case, we're given 11 and we're given a set of coins, and assume we can pick 1 as many times as we want, we can pick 2 as many times as we want, and we can pick 5 as many times as we want. Okay, what's the least amount of coins we have to pick to make up 11? And in this case, is obviously pick 5 twice, okay, and then pick 1 once, so that's 3 coins. So let's just kind of picture what this problem is asking. So going by this example, okay, it's saying if we're given the problem, let me get a black color, not red. Okay, so we're given the problem f of 11, where 11 is the amount. Okay, we want to figure out how we can make up $11 or whatever from the set of coins we were given. Okay, so I'm just gonna write the coins. Coins is 1, 2, and 5 is the coins, and amount is 11. Okay, so f of 11 is what I'll say, function of 11. Okay, so obviously there's 3 choices from 11. We can pick 1 coin, okay, and that would just lead us to f of 10 because we're gonna have 10 left. Okay, we can pick 2 coins, that's gonna lead us to f of 9 because 11 minus 2 is 9. Okay, or we can pick the fifth choice is 5 coins. Okay, we can pick 5 coins. Okay, if we pick 5, what are we gonna have? 5 minus 11 is f of 6. Now again, let's continue from this 6th leg. Okay, 6 at f of 6. Okay, at f of 6 we have 3 choices. We can pick 1. We pick 1, what are we left with? F of 5. Okay, if we pick 2, what are we left with? F of 4. Okay, how about if we pick 5, which is our third option, right? What are we left with? F of 1. Okay, now let's focus on this one. Here we have 3 choices. We can pick 1. What are we left with? F of 0, which is our base case because we know how many ways can we pick 0 coins. It's just 0. So f of 0, we can say is 0. It's our base case. So we know this guy is 0. This is our base case. Okay, but let's explore the other choices. We can pick 2, right? And this is going to be f of -1. Can we make -1 coin? That's impossible. So we need somehow in this algorithm to say, hey, whenever we're less than 0, just stop. Don't do anything. So there's no point in me checking the third leg where I have to pick 5 because that's going to be f of -4. So we don't care about this. 0 is our base case. We know from 0 there's 0 ways to pick it. Okay, and then we can come here and trace this leg. Okay, trace how many times we picked. Obviously we pick once here. Each arrow is how many times we picked. We picked once here, we picked once here, and we picked once here. So that's f of 11 is equal to 3. Okay, that's how we get value. Again, I can go through and trace other legs, but to be honest, it's just gonna be a waste of time because no one is gonna beat these 3 legs we just. Let's go ahead and try one more. Let's try this 5, right? Because if we try 7, if we try 10, there's no points because it's just gonna go into more trees. So let's just do this 5th leg right here. Okay, at 5 I have 3 choices. I can pick 1 coin, that's gonna give me f of 4. At this point, this f of 4 is the same as this f of 4 here, and we know it's just gonna lead us into some mess, so we can just ignore it. Okay, you can pick 2 coins, it's gonna f of 3, or you can pick 5 coins. Okay, this is gonna be f of 0. Okay, this is another base case, so let's count how many picks it took us to get here. Okay, it took us 1 pick here to get to f of 6, it took us a 2nd pick here to get to f of 5. Okay, we picked 5 coins here, picked 1 coin here, then we picked 5 coins again. So this set is just picking is 5, 1, 5. Okay, which is 3, kind of like we got here. Okay, for this set we picked in an order of 5, 5. So we picked 5 twice and then picked 1. This was the set. That's how we got 3. Here we just, it's the same items but in a reverse order. Let's put this finding to code. Okay, this is called a top down approach. However, we can also do this using a bottom-up approach, and the bottom-up approach is pretty straightforward. The bottom-up approach just says, let's create an array, okay, where, so in this case, we're gonna have where our indices runs up to the amount we have. So this is our index 0, index 1, index 2, index 3, index 4, 5, 6, 7, 8, 9, 10, 11. And this is just, I put it as 11 because we were given an amount of 11. So each index in this array represents the amount we're trying to get. Okay, we'll create an array. We know the base case is 0. To pick 0 amounts, you need 0 coins. Okay, now we want to go in and start filling this guy up based on the values we calculated. Okay, so we know to pick 1 from this set we're given. To pick 1, all we have to do is just pick this one guy, 1 coin. So we know she's gonna be 1. Okay, so keep in mind f of 1 is equal to 1 plus, if I call this array dp, okay, plus dp of 0. That's all he was, dp of the previous guy, 0 index. Okay, so now to pick 2, okay, how many coins are we gonna need to pick 2? We're gonna need 2 coins, obviously, right? Because f, we're gonna pick 1 twice. We're gonna pick 1 once and 1 the second time, so that's 2 coins, right? So f of 2 is just equal to 1 plus dp of 1. Okay, f of 3 is the same. It's going to be equal to 1 plus, so this is 2, this is just 1, plus dp of 2, okay, which is 3. So in this case, we've exhausted all our, this is the minimum, we've exhausted all our ones. We picked 1 twice. Now to make 4, okay, 4 is going to be, so f of 4, this is kind of tricky because I know you might want to say he's 1 plus dp of 3. In this case, that will give us 4. But no, that's not the minimum. This will give us, if we pick 1 4 times here, it will give us, but that's not the minimum. He's also, his minimum, okay, is going to be, we can pick 2 twice. 2 twice. So literally, we can pick 2 twice. Okay, so if we pick 2 the first time and we pick 2 the second time, that's just going to give us only 2 coins. Does that make sense? I hope that makes sense. Okay, so we're going to put this to code and you guys can see what's going on. So like I said, first thing we're going to do is create our DP array. Like we said, this is the guy that's going to keep track of everyone, kind of like we explained in this example. He's going to be this array that keeps track of everyone. Okay, so on the first one, DP array, we're just going to set him into, it's best to set him to as maximum as you can. So you can set him to any amount higher than this amount because we want to find the minimum, okay? But preferably I'm going to set him to infinity. Okay, so, and how many elements are supposed to be in here? Keep in mind, since it's 0 based and we want to go up to amount, okay, we're going to have amount plus 1 element. Okay, so now we have him filled with infinity. Okay, so next we're going to initialize our base case. Our base case is dp of 0. We know he's 0. Okay, that's straightforward. Now a for loop, we're going to iterate for a in amount. Okay, so actually not in amount, for a in range, okay, length of dp. Okay, so I'm just iterating through each amount. Remember, in this dynamic array, this represents 0 is the amount, 1 is the amount, 2 is the amount. This is the minimum amount of coin to get 2, minimum amount of coin to get 3, minimum amount of coin to get 4, all the way to whatever amounts we're given, minimum amount, the minimum number of coins to get up to the amount we're given. So that's what we're doing. So we're iterating, each of the indices in this array represents the amount. But for each amount we're given, we also want to iterate through the coins. So we're going to say for c in coins. So now we're iterating through each coin for each amount, so through our array of coins right here. Then what we want to say is we want to say if amount minus that specific coin, okay, is greater than, meaning amount has to be, meaning we can at least take out the coin from this amount. Amount has to be greater than or equal to this coin. It shouldn't be negative, kind of like we explained here where you reach the base case of 0. Okay, negatives we just cancel, we don't even bother looking. Okay, so here is up to our base case, up to where we get to 0. Okay, if that's the case, we want to calculate our dp of that amount. Is just going to be equal to the minimum okay, of him, whatever he was before, and okay, 1, because we're simulating, we take that coin 1, okay, plus dp of, once we take the coin, what's going to be left? All that is going to be left once we do take the coin is the amount minus the coin. Okay, I hope this kind of makes sense. That's pretty much it. And then once we're done with this for loop, we're going to populate our array completely, and then we can go ahead and return dp of amount. Okay, we also want to return -1, kind of like example 2 says. If we can't make up the amount, we want to return -1. So we want to say return dp of amount if dp of amount, okay, is not equal to the infinity we set him to original, the garbage we put in there original. If he's not equal to this, I'm just going to put a parenthesis around this guy. If he's not equal to this, return this. Else, meaning he wasn't changed, return -1. So this should be the answer. Let's go ahead and submit it. Oh, bam, that wasn't bad. Okay, that's 53%, and in terms of space complexity, that's awesome. So something else we can do is, because it's not in every instance this coin is going to be sorted like it is now. So something else we can do to kind of make this more efficient, slightly more efficient, okay, is we go ahead and sort it. We sort our coins. So we say coins sorted in place, okay, and then we go here, this if statement. So we're saying if this, do this, okay, else. There's no reason checking the else case, meaning where this number is negative. So let's just break out of this loop so we don't waste time running this loop. Let's just break out of the rest of this. We don't have to keep checking. It's kind of like a case like this where we reach 0, but we keep going down, keep going down, keep going down. We don't want to do that, okay? We just want to stop. Okay, so else break. Okay, let's try this now and see if it's better. Okay, so it went from 50 to 61. So that's it for the video, guys. I hope it was helpful, and I'll see you guys in the next one.